The overall goal of this procedure is to cool an optically trapped ultracold Fermi gas to the microkelvin regime by periodically modulating the intensity of the trapping laser beam.
This cooling method can address the key questions in ultracoldism research, such as generating lower temperature quantum gas for simulating novel phenomena in nature. The main advantage of parametric cooling is that it can cool ultracold fermionic lithium-6 atoms with very high cooling efficiency. This complicated procedure will be implemented by our postdoc Jiaming.
The apparatus for this experiment is already in place. There are several key components, starting with the oven. The oven will output lithium-6 at the required flux. After leaving the oven, the lithium travels through a Siemens lower and crossover coils. From there, the atoms reach the experiment chamber. The chamber is between coils that have either a Helmholtz or anti-Helmholtz magnetic field. A photodiode monitors the fluorescent signal through the chamber window. There is also a CCD camera to image the atom clouds through an infrared cutoff filter during the cooling and pumping phase. Surrounding the chamber are lasers and optical elements for magneto-optical and optical dipole traps to cool the atoms. Much of the experiment is computer-controlled by a timing file entered into the control software.